Which one are we looking at? Number 2?
No, I'm looking at number 1. You did a last one. Oh, I have multiple on number 1.
Okay. We have is that my phone? Did y'all hear that? I'm losing my mind. All right. I'm gonna run through. What did you say, Armando?
What one are you doing?
All right, this is number 1, and I'm just gonna run through really, really quickly on these. If you need me to slow down, holla.
Are you doing all of it?
All right. Well, because you have the first one's just the derivative. A lot of them you have to go in order to find the previous part. So velocity here would be 3t squared. My pen is glitching. Minus 24t plus 36. Okay, there's my velocity. So that's part A. Oh no.
Oh, I see that one. Oh, my whole thing is going to be all messed up because I didn't multiply 12 and 2.
I take it you didn't do it.
No, I did that one.
Okay.
Oh my gosh.
Velocity after 3 seconds would be v of 3. That's all you do.
Oh, my whole thing's about.
Can you have a negative velocity? Yes. What does negative, this is meters per second, by the way. If you did not put the units, make sure you go back and put the units because those are imperative. Oh, pass this back from the no. Trig Derviatives, that's for Nicholas. Can you have a negative velocity is what I was saying. You can. What does that indicate? Left or right or up or down? Right. So if I'm negative, I'm either going left or down depending on the way the problem is written. This one does not say, so we're going to say left. Doesn't matter. When is the particle at rest? How do I tell when something is at rest? What's at 0? Velocity is at 0. So I want to know, when is this equal to 0? Well, this is a factorable. I'm going to take out a 3, 8t plus 12. You plug in 0, that tells you the velocity or the position when the time is 0. But if you set it equal to 0, that's when is it at rest. So t minus 6 minus 2. If I were to get a negative value for t here, I would omit that because I'm not a what? Time traveler. That's right. All right, so t equals 6. T equals 2. That means what, Rhett? It's at rest at 6 and 2 seconds. Doesn't tell me where it is. It just tells me that it's stopped. Yes? All right. When is the particle moving forward? So I need to do this little sign analysis, right? So this is where, do y'all remember in pre-cal when we did these little sign analysis?
No.
I don't think it.
Did I skip that? Well, we're doing it today in pre-cal, so maybe I just skipped it with y'all for some reason. Polynomial inequalities. Okay. All right, so remember I'm plugging into velocity to tell the sign of velocity to tell what the particle is doing. So if I plug in 1, and remember I start at 0 here. So if I plug in 1, I get a negative times a negative, which is a positive, so I'm moving to the right. Between 2 and 6, so it's negative. And then bigger than, yeah, we already did 3, look. So that was negative. Bigger, 8, I'm going to get a positive, and I'm going up. All right, so, yeah. Yes, that's what you're plugging into. Well, I haven't answered it yet. D says, when is it moving forward? 0 to 2 and 6 to infinity. That's the forward motion. That's where it's positive. Find the displacement after 8 seconds or during the first 8 seconds. So what does displacement mean? Final minus initial. Is that what you said? Oh, that's wrong. A-rock is average rate of change. Huh? No, I'm not making this up. Do you want a Pop-Tart? Oh, okay. There's some cheese to dip them in. William said that cheese is good. There's some, what, there's some, no, stop, you'll leave William alone. Just ignore them. Just ignore them. I'm gonna make them eat that cheese for lunch. I will. Okay. Yes. You will not pass this class if you do not eat a cup of cheese. Are you okay? Do you feel sick? No, it doesn't. Don't say that. Okay. What? All right, so displacement, first 8 seconds. So I need initial and I need the terminal end. So initial would be S of 0. So where did, I forgot his name. Larry. Where did Larry start? So at time 0, he was at position 0. That's nice. At time 8, where was Larry? Plug in 8 into the position equation. That's the very initial one. So S of 8, what is it, 32? So what's the displacement over the first 8 seconds? 32 meters. Don't forget the meters. Sometimes that can garner you a whole point just from having the units right. No, we didn't skip that. Did I tell you to skip that?
Number 2.
I always make homework.
Yeah.
I got on the last question here.
No, we're just on the first one. All right, total distance traveled. So what I'm going to have to do is I'm going to have to find, I've got S of 0. I'm going to need to know S of 0, S of 2, S of 6, and then where did it end? What did it say? The first 8 seconds? And S of 8. Now I know S of 8 is 32. S of 0 is 0. What's S of 2? 32? Are you sure? Total distance traveled F. I just made it. I forgot to make it. It's 0? Oh my gosh, let me use the calculator. Minus 12x squared is 36x. All right, what do we say at 2? 2 is 32. 6 is 0.
You have plug it in. Plug it in 2, you get 4 times 3, 12, minus 48. Well, how do you get, how do you get 32?
Bro! You're using position. So S of 2 would be 2.
Hey, that's the original place. I
He just told you. He hasn't been here for a week and he's telling you and you're not even listening to him. I said S of that. S. Which one is S? Sweet Lord. Okay, but I still haven't answered the question, right? So understand what Larry did. Larry went this way for 32, right? But then he turned around and went 32 back to 0. But then he went 32 this way again.
Someone crossed Amia's name off and did my name.
It might have been your brother. No.
Yeah, he had names like that, but he didn't.
He went 96 meters. So the total distance traveled different from displacement, right? Total distance traveled, and that's mainly because he was just indecisive about where he was going. He went 32, 32, 32. So he went, what did we say, 96? Meters. F. Is that what you got? What'd you get for displacement?
What? You're on F or G?
Okay, so I'm on F. Mhm. Yeah. 96. Huh. What about you, Lane? I think you must be looking at the wrong one.
I'm looking at one.
Okay.
Oh, I did it.
I was gonna say, okay. All right, so then it says part G says draw a diagram. I've already drawn a diagram. Acceleration at time t, that just means take another derivative.
That's the acceleration.
So acceleration would be what? 6t is the derivative of velocity. That's exactly right. What units would my acceleration be in? Oh my gosh. Meters per second squared. Look at you, Gina. Look at you. Meters per second squared. Then it said the acceleration after 3 seconds. Plug in a 3 there. 18 minus 24 is negative 6 what? Meters per second
So is
squared.
that H? Wait, so what was G? Plug in 3.
What? G was draw a diagram. That's the sign analysis that I did.
I already did that.
Yeah. Acceleration is H. The I's the one I told you to skip. When is the particle speeding up? When is it slowing down?
Okay, that I need to explain.
Okay, so, all right. So I'm going to take this little sign analysis for velocity. Here's velocity. Here's position. 0, 2, 6. I'm just doing that. You don't have to. I'm just doing this so that you can see positive, negative, positive. And then acceleration. When is acceleration 0?
So
If I set this to 0, that only happens at 4, right? Are y'all following me? When is acceleration 0? You make it equal 0. The acceleration equation, right? So I plug in smaller than 4 and bigger than 4 to see positive or negative. So if I plug in 1, negative. If I plug in 5, positive. So here's what I'm looking for. And this break is happening here, but both sides are negative, right? Here are my intervals, right? So this is negative, negative. This is positive, positive. So where are they the same? Where are the signs the same? So speed up. I don't know why my pen's laggy. Speed up 2 to 4. Anywhere else? 6 to infinity. Slow down. Opposite signs. 0 to 2. Is that it? And 4 to 6. I think the hardest part for me is getting the signs right, just finding where these places overlap.
So is that all the questions they would ask?
Yes,
Every
for right now. You might have an FRQ that says it would be a contextual like it would be the number of cars entering the car wash enter at a rate of blah. At this rate, what's the, but in other words, it'd be like a real life application problem like that, but they're asking the same thing.
I got
Welcome. Got lost on 2?
You're going to need to do all of 2.
Yeah.
Oh my, y'all. Okay. All right. T is seconds, X is meters. This one gets confusing, I think, because they use X as the Y variable like that, so it kind of starts to throw you off a little bit, but it's still, we need the derivative. So velocity, I tend to always start these out by doing this, velocity. Now this is a fraction, so to find the derivative, what do I have to do? A quotient rule. So derivative of the top times the bottom. No. Why? top times derivative of the bottom. Why? Shut up. I could clean it up a little bit. What are you doing? Airball? Airball. 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 Oh.
First question. I saw Gina Saturday night and she looked absolutely gorgeous. Let me tell you.
Gina always looks gorgeous. Why would you think she only looks gorgeous then?
I always think so.
It's a paramount. What, Marky told me she's gonna have to do that. Marky went on Monday night dancing with the stars, and she said, he said he's ready to do that.
He's gonna flip for you, Gina.
I'll be watching.
I thought your Twitter would come by. It broke my heart.
I don't know what you're talking about. No.
All right. There's the velocity.
You don't know them.
Does it ask me about acceleration? Oh. Let me go ahead and find the acceleration. Okay.
And then we have to like solve it for zero.
Okay, so that's not as hard as you think it is, and I'll show you why. But for this, I'm going to go ahead and multiply this bottom out. I'm just going to FOIL out the bottom 1 plus, because y'all haven't learned.
Wait, what is going on? This is velocity.
Now, if I didn't need acceleration, I would stop right here. But if I need acceleration, I need to FOIL that bottom out. And I know I'm eventually going to need acceleration, so I'm going to go ahead and find it. So I'm kind of mixing up the order we're doing. This is actually E. I know, I'm going out of order. This is...
I don't think I did acceleration right, because I got like 1.
Okay, well, let's see. Derivative of the top times the bottom minus the top times derivative of the bottom. We are, but I skipped down to E. I am not going to clean that up any or do anything at all with that unless I have to. And I don't have to right now. I don't ever do any more than I have to.
So much going on.
There is some.
I'm trying to get over.
Okay.
Sing that rap. Oh, you know, 13.
Lan, we have to get a picture together today before you leave. Yeah. I love it. All right. So let's look at part B, right, Armando?
But dude, we should just go in order.
We are. We're going to B now.
We already got that acceleration before the acceleration. Which that's the whole thing.
Oh dear Lord. This is A, this is E, now I'm going to B.
Oh, wait, okay, out of order. So we just say, hey, we just do anything. E, C, D, just bring the whole thing to
What is going on? Why can I not do A, E, B? That's how my alphabet goes. Thank you, thank you. All right. Tell me, Rhett, how do I tell if it's going to the right or left? Do the number line thing. That's exactly right. When it's positive, it's moving to the right. When it's when what is positive and negative? Velocity. Velocity. So, all right, look. I got to set velocity equal to 0. Now here's where it gets sticky, right? Because oh my gosh. If I have a fraction that equals 0, the only way to get 0 when you have a fraction is if the top is 0. If the bottom's 0, I'm undefined. That doesn't make it 0. So really, if you're ever in this situation, you just take the top and you say, when does that equal 0? That is a much easier solve.
Positive 1.
So positive and negative 1. One of those answers does not make sense. Which one doesn't make sense? You can't be a time traveler. I can't go negative 1. So 1's the only one, right? So Lord. Shut up. Just shut up.
Thomas has this theory about like energy consumption that he presented us last year.
That was a really good question.
I'm still thinking about it.
I truly think. You remember what you presented about?
What did he do about?
Oh, you weren't there? Oh, I have a video. Dyson Spears will. No, Dyson Spears, I totally agree with Tom.
The Dyson Airwrap.
It just. I can present it here. Yeah, it was a really good presentation. I think I had a really good presentation.
I don't know what's going on right now.
I don't either. Holy crap. Okay.
Alright, plug in 0.5. I have a question.
All right. Armando says plug in 0.5. I tend to agree with Armando on this. Now look, why do I not have to worry about the bottom here?
Because it's going to be negative.
No, but look, you're close, but it's not going to be negative.
It's going to be undefined.
No, y'all, look at it first. Look at your velocity equation. This is my velocity equation. What's going to always be true about the bottom? What kind of number?
Positive.
Why?
Because it can't be negative.
Because it's an integer.
It can't be negative. The bottom can't be negative because it won't be
In square. I appreciate y'all just regurgitating everything I've said at some point, but
What is the answer?
the bottom is always going to be positive because it's squared. So I don't have to worry about the sign of the bottom. I'm only going to worry about the sign of the top. These are some of those little things that will help you on an exam in a time constraining manner that you can, or in a time restricting, whatever, y'all know what I'm saying, environment. There you go. 1 minus a half squared would be 1 minus a quarter, which would be, so that's positive. If I plug in something bigger, Rhett, maybe I plug in 5, what do I get? Positive or negative? Positive or negative, Rhett? Focus. Okay, you had a 50-50 shot, you blew it, it's negative. Yeah. The velocity equation. So this down, that's why I always write velocity down here. That's what you're plugging into, and it's telling you what this one's doing. All right. So.
Wait. The question that's over the velocity. That's not even. We're not doing the
It says, when is the particle moving to the right?
Oh, I was looking at 20.
I am fixing to chunk something at all of y'all. Yes, Brad.
Move it right 0 to 1. If somebody.
Thank you, Armando.
That's how we know.
Yes, positive or negative.
No,
No.
Nope. Do you think we should be able to use them in like giving experiments? No, I like to agree with that.
If somebody what?
If somebody's on death row, we can use it for experiments.
No, Brett,
Oh my God.
can we focus on calculus?
No, no.
In space. We want to go to Mars. Get through me. Send him up there. He's just dying.
Total distance traveled.
95% we want to do that.
This is not the total distance traveled.
This is not total distance traveled. This is total distance traveled. All right, I need the position at 0. Then I need the position where, Armando? At, no.
Wait, which one are we?
Okay, at 4, but I also need it where it changes direction. At 1. So before, so I need S of 0, S of 1, and S of 4, because if I just take the initial minus the terminal, then what's going to happen is I'm going to have displacement and not total distance traveled. Oh, Oh, sorry, we are finding displacement. Okay. We'll do them all right here though. We'll do both of them. S of 1 is 1/2. I'm going back to the original. What's S of 0?
0.
Huh? 0? Oh, it is X. Sorry. Okay. It's 0. And what's S of 4?
Wait, what are
No,
we
it's
plugging
not.
this into?
Yes, it is. Yes, it is.
What are we plugging this into?
The original equation. The original equation. All right, so let's look. Difference in total distance traveled and in displacement. Displacement is 4/17 meters minus 0, which is just 4/17. But total distance traveled, so I start at 0. I move to the right 1/2, right? And then I move back until I get to 4/17. But how far did I travel? I didn't go back to 0. So you've got to subtract them. That's exactly right. So do y'all understand what I'm saying? All right, if I'm on a number line and I'm at 0, right? Here's my bug. Rat, shut up. He goes over to 1/2. But then he moves backwards. He doesn't go backwards 4/17 meters. He goes to 4/17 meters. So he ends up here, then he stops, and he goes back to right here. So the question is, what is this distance right here? It is total distance traveled, but understand how I'm finding that. Shh, boys.
Oh, so you're trying to find that so that you can add that?
That's exactly right. So this is 1/2. I know he moved to the right for 1/2. But when he moved in the other direction, he stopped at 4/17. That doesn't mean he went 4/17 meters. He went from 1/2 to 4/17. So how far is that? You got to subtract them. So 1/2 minus 4/17 would be 9/34. So total distance traveled, 1/2 plus 9/34.
Over 17.
13/17.
14/3. What's the answer? 13/17.
That's total distance traveled. He rests at he rests at 0.5. 25.
I know, that was still, I was doing it in my head, right, but you're like, yeah.
I don't mind. I'm not just telling anybody. All right, let's brother. What? Oh Lord. So I need the zeros for acceleration. So I'm going back to this acceleration equation. Holy crap. Only the top though. Only the top. So negative 2t minus 4t cubed. Y'all watch me make sure I don't make any mistakes. Minus 2t to the 5th. Minus, oh, gross. 4t plus 4t cubed. Minus 4t cubed. Minus 4t to the 5th. Are y'all watching and making sure I do this correctly?
I'm doing it by my mind. So we get
All right, so I got 2t to the 5th. Don't have any powers of 4. Minus 4t cubed. Minus 6t. Should be what?
No, it's those 4.
Negative 2t to the fifth.
Plus 4t.
Oh, yeah, plus 4t to the fifth. Because it's minus. There's a minus in front of there. All right, I'm setting it equal to 0. I'm going to pull out a 2t. It leaves me with t to the fourth minus 2t squared minus 3. This is a quadratic form. T squared minus 3. T squared minus 1. Holy cow, I've got t equals 0. Well, that's where I start. Right, Armando? T equals plus or minus square root of 3, but A, negative doesn't make any sense, so it's just square root of 3. And T equals plus or minus 1, the negative doesn't make sense, so 1. So I've got 2 places acceleration is changing signs at square root of 3 and 1. Well, look, velocity also changes at 1. Is square root of 3 bigger than 1 or smaller than 1? It's definitely bigger. Right. Square root of 3. All right, signs. This is a lot, y'all. Acceleration here, where's my factored acceleration? The bottom again is always positive, so I don't have to worry about it. I'm just going to worry about the top. I'm just going to worry about this piece. So between 0 and 1, if I have a half.
Bro, I gave up after acceleration.
This one's always going to be positive because I'm only putting positive numbers in. Times, if I go a half, that's a negative. Times a negative, I got positive. Should be positive, negative, positive. That's not what you got. You are correct. You are correct. Thank you. That should be t squared plus 1, which is going to give me imaginary numbers, which isn't. So it's only square root of 3. I know. Sorry. There you go. All right, we are switching from here. We are switching gears. I have these, which, by the way, Anna Martin has texted me multiple times, and she said that she's in Calc 2. They are having to derive all the trig and inverse trig functions by hand.
Oh, you're lying.
Like with the difference quotient. Like plug them into the difference quotient and all the trigs. I have never had to do that by hand before, but they don't get a calculator and they have to derive them by hand as one test code, and then, yeah. She was like, just give me my green sheet back for Calc 2. She's, yeah. But what I was saying is I wish I could tell you an easier way to do it than just memorize, but believe it or not, memorizing them is the easy way to do it, is what I'm getting to.
So how are we going to memorize them?
We can do Kahoots. You can put them on flashcards. Y'all, I remember whenever I got certified to teach AP Cal, and I was doing it through Coastal, and that's one thing. I mean, that's if you don't memorize the derivative of cosecant x. I mean, if you don't use it, you're never going to remember it. You know what I'm saying? So I remember driving to Coastal on the way to Florence with flashcards as I'm driving down the road, because before you can get certified to teach AP Cal, you have to take the AP exam. And I knew that the only thing I did not know was I did not have my trig derivatives memorized. And I was stressing because I was like, oh my gosh. But anyway, so I feel your pain. If I could not get a 5 on the exam and I'm teaching y'all, there's something wrong. I mean, seriously.
Oh, well, why did you think you would take 5?
Oh, because I wanted 100. Like, I wanted to get everything right.
Oh.
And that was the one thing. No, I had to Who are all the people in algebra because they couldn't do their anyway. All right, trig derivatives. I'm just gonna go ahead and tell you you'll hate this part. What do you say, Peyton? I said they're gonna hate this part. What do you think? And then you derive it from there for all of them. Not with difference quotient, but you use those and rewrite them. And all right, here we go. Y'all, this is, I mean, I'm writing this, but this is on your green sheet. Okay? The derivative of sine x. All right, listen up, listen up. Here we go. This is good stuff. The derivative of sine x is, you ready for it? Cosine x.
And we know that because when you plug it in.
If we did the difference quotient and we went through it, we would derive it. We would see, but we're just going to memorize them because gross. Right, Rhett? What's the derivative of sine x? Rhett, what do you think the derivative then is of cosine x? You're very close. Negative sine x. No.
How is that possible?
I mean, I could show you the how if you want me to. I know. I'm telling you, y'all, like, I don't want to do y'all a disservice if you really want to derive them and they show you.
No, we will never do it. We will never have to do it.
Not here.
So d over dx is the derivative, right?
Yes. Derivative of tangent x. Secant squared. Now look, this is the one that Peyton was saying that he doesn't memorize all of them. He just does sine and cosine and then gets them from there. In other words, you could write tangent as sine over cosine.
Right.
Then you could do the quotient rule.
No.
And you would end up getting 1 over cosine squared, which is secant squared. And you can do all that. And you may get yourself in a position where you have to do that because you can't remember a certain one. And that's fine. It doesn't take as long as it sounds like it takes. But just in case you can't remember, you can do that. The derivative then, so we got sine, cosine, tangent. Then we do the derivative of cotangent. Cotangent is just the flip, right? Just the flip of tangent. So what do you think the derivative of cotangent might be? Negative cosecant squared x. Now, there's a pattern here, and I'm writing them in different numbers because I want you to see that. In fact, any trig function that starts with any function, the derivative is going to be negative. That's going to be a little trick to help you remember. 2 more, and then we'll play around with these and see what happens. 10:38.
No, wait, sorry. What's
The 22nd. I know, this is literally just memorized. Do you? All right, derivative of secant x. Armando, what is it?
I don't understand how you're doing it. How do you just memorize it? Yeah, I don't know.
Hey, do you have this sheet? Yeah, you do. I made you all one, and I said, do not lose it. It is laminated. And it's going to be your Bible for a while until you...
I lost it. So that's a double?
Derivative of cosecant is negative cosecant x cotangent x. All right, we're going to stop with those 6 today, and we're going to play around with those, and we're going to work on derivatives. All the rules of derivatives still apply. We're just using, oh my gosh, get out your green sheet, Armando. BT dubs. That means, by the way, for those of you who don't speak that kind of language. You're welcome. You're welcome. I thought you might need an interpretation. Our test is coming up because this is the last.
No, please don't put it this week. This week
No,
not
you
okay.
put it on
Here Friday, I gotta lock in.
This week,
Don't do anything.
like, just do it next week.
Do it Monday, bro. Study
I won't be home.
I'm okay with Monday, as long as it's not this week.
We are already 10 days behind.
Yeah, well,
I will do it
Listen,
Monday.
you understand that it's one more week?
I'm not focused on
I haven't. Okay, and y'all have used that until we don't have the whole year now. I have y'all. It was supposed to be Thursday, but I pushed it to Friday because I'm not. Yeah. Remember, you've already taken a test on half of it. The only thing we added on there since the other one was the particle motion.
So it's the morning after the homecoming parade?
Mm-hmm.
They're gonna interrupt us to make the test and ask us to go. No, yeah, we're supposed to go Monday.
When am I studying?
Like, I can pray or catch up last week. We'll walk in through. Or I'd rather a Monday test than a Friday.
Thursday or Friday?
Neither. Well, Wednesday night we were swimming.
Friday.
This week it's like swamp. Like,
I know.
This week is Monday.
I just can't push it till Monday. We're so behind.
Oh, that's
All right, let's talk about today, and then tomorrow we'll look at this.
Honestly, maybe Wednesday would be better. We're just thinking of
No. Review tomorrow. That's Wednesday.
Is it stuff that it I'd rather Wednesday. No, I don't know. Maybe. Oh, well, what's gonna be on it?
Derivative rules. So we started this unit with the derivative rules, the shortcut, all the power rule. Remember, you took the test on halfway through.
Yeah.
The only thing added since that test, when you've got that test, is particle motion and what we're doing today. This is just, and you'll use your green sheet on the first test.
Those couple of days. I would look at Friday. Maybe fine.
I don't want you to feel swamped about it. I don't want you to feel overwhelmed.
It would be nice to have like the days.
But-
the days
Right.
of class review. Yeah. Okay.
Watch this and see how you feel about this, because you'll probably change how you feel about things whenever you see this. Because we're marking off marginal cost, we're marking off a lot of that kind of stuff that's not going to be. We're not doing harmonic motion. All right, let's see what you think. I think when you see this and knowing that you got your green sheet, you'll just say, "Oh my gosh, I've really already done this." Okay, close. Now, what's happening here? What's happening here? It's a product, right? So to find the derivative, I'm going to have to do the product rule. So the derivative of y is going to be, I do the derivative 2x times sine x, Armando, plus the first times the derivative of the second. That is literally it.
That's all you do.
Oh, and we can use our sheet.
And you can use your sheet.
That's the answer?
That's the answer.
Does it have to-
Now, no.
Let's go on before I.
Armando, your gums have been bumping this whole time. Find dy dx.
Why, yes. Alright, so what is that? What is this? This is the quotient rule.
Oh my gosh. You did not just ask that.
D over dx derivative.
So the derivative of y with respect to x. This is the same thing as saying this. Newton versus the Lou person. All right, I have a fraction.
So derivative of top.
Derivative of the top. What's the derivative of cosine x? Negative sine x. Negative cosine x. Yes. All right, derivative of the top times the bottom minus the top times derivative of the bottom. What's the derivative of 1 minus sine x? Negative cosine x. All over the bottom squared.
That's it.
I need to clean it up just a little bit, okay? So,
Make it square.
okay, so you got negative sine x plus sine squared x plus cosine squared
I
x.
do that sine squared. Oh, okay.
Now look, if there is one and only one trig property that you memorize, I told you, do you remember what it was that I told you?
Sine.
Yes, every time. Make sure, if you don't know any other ones, that you recognize that one.
Oh, so
That's just one.
That's just one.
Really? What? I know. Like, say it again.
Sine squared plus cosine squared is 1. Know every version of that. Sine squared is 1 minus cosine squared. Cosine squared is 1 minus sine squared. Or sine squared plus cosine squared is 1. Always know that and recognize that. If you don't know any other one, that one pops up more than anything else.
Wait, and would the top simplify that? Just 1 over the sine x?
Okay, so the top simplifies to 1 minus sine x over 1 minus sine x squared. And now what do you notice?
Take it away. Top.
Take it away. Take away the top and 1 from the bottom. And so this derivative is just 1 over 1 minus sine x. It's really not terrible.
That's not also cool.
Yeah, you could. Una mas. This one's for you, Rhett. Una mas, and I'm done. Find an equation of the tan line
Which is the derivative?
at x equals 2. Find the equation of the tan line at x equals 2. This is my one.
That's not your best decision.
Why are we talking about?
That was more fun. That's what she made.
How are you back there so fast? Because I have to stand here like
You're
on top of
asleep?
Armando.
It's a work.
What do I need to write the equation of a tan line?
Derivative.
Derivative. Well, how do I write the equation I need? The derivative gives me the what?
Slope.
The slope. I need two things to write the equation of a line. A point and a slope. Okay, a point and a slope. Anytime you see tan line, not to be confused with this kind of tan, but anytime I see tan line, I know I need a point and a slope. Right, Armando? How do I find the slope? This is the derivative at 2. How do I find the point? Plug in 2 to the original. So now I know what I need to do. I just have to find them. So the derivative, you see how we're doing the same thing over and over, but we're just learning new techniques to, now we know how to find the derivative of tangent.
Yeah, you missed
Okay, so
Yeah.
1 over cosine, but you got to make sure you're in radians. All right, here's where you're going to have to know your unit circle. Rhett, could you please stay with me? Let's first find derivative of f. Go, Rhett, do it. Derivative of f, do it. Talk me through it. Come on. Derivative of f. Stop looking at them
I
and...
know it. Miss Vicky, I know it.
What?
Secant squared x
All right, so derivative of the top.
times x
Okay.
And then 10x
Minus.
minus 10x.
Okay. All over.
X squared.
So now if I plug in 2 here.
Wait, I didn't write it down. What is it saying?
I don't know my.
Okay, this is not a unit circle value. I'm sorry. You got to use your calculator.
I don't know.
So if you're, listen, because this does come up frequently and you need to know how to do it. So the question is, how do I use my calculator to find this? Secant is 1 over cosine, okay? Secant squared and secant x squared are the same thing. So when you put this in your calculator, do 1 divided by cosine of 2. Do it, Rhett. 1 divided by cosine 2. You're fixing to come up here with me. 1 divided by cosine 2, but make sure you are in radians, okay? Then square that. Subtract tangent of 2. I'm not bad passing rate.
I did.
Pay attention.
I'm not gonna lie, bro. I'm probably failing it. You got it.
What? Yes. Are y'all using this? Tell them, William. Tell them. Just kick him out like I had to do Grayson the other day.
If he doesn't put two, just have more.
You know I've done that before. And twisted the board. I moved the board down there where that whiteboard is, and I taught from down there, and I put somebody out, and I told them I wasn't going to keep them from learning, but they were going to sit outside the door and watch through the window. And okay, make sure your mode, make sure you are in radians. Yeah. Yes.
He did what? Oh, yeah.
All right.
What?
Has he apologized?
He wrote a note. I'll show it to you. So
God.
No. I'm a lucky. That was my last thing I was saying.
Brother, there's a door full. Rhett,
Of course you can see that. Of course.
come here, Rhett. Come here. Come here.
This is the second time we've had this. I think it's much better.
Here's the problem.
This is the second time.
What is going on?
You know what
I'm
it is?
fucking dancing.
No.
Where's your calculator?
I told you I have one.
Oh.
What?
Are they dead? Here.
Oh, one of these.
Okay. Go to mode. Everybody in mode?
Yes. You just have to make sure it's in radians.
Radians. Everybody in radians?
Yeah.
All right. 1 divided by, nope. Yeah. 1 divided by cosine of 2 and hit enter. Now hit the squared button. You should have 5.774.
Yeah.
1 divided by cosine of 2 and then squared. Are you? If you're not in radians, I'll come.
Was I ready? Okay.
Yes, you did.
Okay. That is just this part.
How did you see 1 divided by cosine?
Nicholas, you want to use this one?
1 divided by what? 1 divided by cosine is this. Thank you.
All right. I need us all together. Clearly. All right. Take your finger like this. Push the button that says mode. And make sure gradients is highlighted.
You get negative 4.25.
5.77.
I didn't go back.
Second.
No, I got it. I calculated.
Subtract by
Now hit minus, and it should say answer minus tan 2. Enter. And now divide by 2 squared.
So 4. I got
No, because you guys didn't put it as 1.9.
So you can't divide by 2 squared. Yeah, I think we're correct.
What did y'all get? The slope, it should be, the slope should be 3.433. All right, so 1 divided by, oh, she's right.
You need something back.
What?
You need something back.
Why? 1 divided by
This is you should do what it's talking about.
squared times 2 minus
Whoa.
divided by.
Yeah, I'll just get it for the crash.
Why don't you divide by, I guess the subtracting the tan two and dividing by, why did you?
I know what I do. Because secant is 1 over cosine. I know what I do. You don't have a secant button on your, yeah. That one you do, yeah. So this, I put in my calculator is 1 over cosine 2. That's why. Then square root. It's trig is. All right, 3.433. Look. Don't let him distract you. Don't let him distract you.
I'm tired.
That's wrong.
If I was like, I would definitely do it.
Okay, then multiply by 2. Subtract tan 2.
Minus, how do you do that?
So hit minus tan 2.
13.7.
Now divide by 4.
3.4.
There you go.
You watch me do it. With me, you watch me do it. You did the whole thing for me, basically.
We forgot to multiply by 2.
Wait.
1 divided by cosine.
I didn't even know this.
You go walk in.
Plug it in. Make sure
I
you.
did.
Okay. All right. Are you with me now?
I'm ready.
Okay. I still have not written the equation.
Oh my god.
I've got to find f of 2.
All that work.
So f of 2 is tangent 2 divided by 2. Use your calculator again. What is tangent 2 divided by 2? You should get 1.093. Write the equation of the line. Y plus 1.093 equals what is that? Of the tan line when x equals 2. What if I asked you to find the equation of the normal line when x equals negative reciprocal? That's right.